Dear students, do you want to get into the fascinating world of physics? Please see this video and also subscribe to this channel.
Dear students, in this video we are going to study about the image formation in spherical mirrors. The image which is formed by spherical mirror can be found by ray construction, which is called as image tracing. To locate an image point, a minimum of 2 rays must meet at that point. So we can use at least any 2 of the following 4 rays as shown in this figure. So here there is a spherical mirror in which there is a ray which comes from an object AB. So one of these rays is starting from the point B. It gets reflected from the mirror, and that ray passes through the focus. Next, the ray which comes from the point B from the object passes through the point focus F, and it gets reflected from the mirror, and it goes parallel to the principal axis. The next diagram, you see that an object is placed here AB, and the ray comes from the point B, passes through the center of curvature, and it falls on the mirror, and it gets reflected from that mirror, and it also again passes through the center of curvature C. Another ray from the point B passes, and it falls on the mirror P, and it gets reflected through this direction. So these are the 4 rays which are very important to draw the ray diagrams. Next, you see that in the first case, a ray which is parallel to the principal axis, that is here, after reflection will pass or appear to pass through the principal focus. That's given in the first diagram. Then you see that a ray which passes or appear passing through the principal focus after reflection will travel parallel to the principal axis. That's given in this diagram. In the third case, a ray passing through the center of curvature C, that is here, retraces its path after reflection as it is a normal incidence. Then in the fourth point, a ray which is falling on the pole of the mirror will get reflected as per the law of reflection, keeping the principal axis as the normal. So these are the things that you should remember. The next case, let us study about the Cartesian sign convention. While tracing the image, we would normally come across the object distance u, the image distance that is denoted by letter v, the object height, that's the height of the object as denoted by letter h, and the height of the image h dash, which is called as image height. And the focal length of the mirror is given as f, and the radius of curvature given as r. Now, a system of signs for these quantities must be followed so that the relations connecting them are consistent in all types of physical situations. We shall follow the Cartesian sign convention for this, which is now widely used, and that is given below here. The first point, the incident light is taken as if it is traveling from left to right, that is the object on the left of the mirror. Then the second one is, all the distances are measured from the pole of the mirror, that is pole is taken as origin here. Third one, the distances measured to the right of the pole along the principal axis are taken as positive. Then fourth one is, the distances measured to the left of the pole along the principal axis are taken as negative. Fifth one, heights measured upwards perpendicular to the principal axis are taken as positive, and the heights measured downwards perpendicular to the principal axis are taken as negative. So you can see this diagram which shows all these points in this Cartesian sign convention. So this is the spherical mirror here, and this is the principal axis. The incident light is falling on the mirror, and here the distance to the left is taken as negative, and the distance to the right is taken as positive, and this is the pole of the mirror. Over here the height upwards that is taken as positive, and the height downwards is taken as negative. So these are the things that you should remember about the image formation in the case of spherical mirrors.